Here in the elemental analysis lab, we can measure elements in different kinds of solid materials. For example, if we want to measure the elements in this rock, we have to crush it, grind it, and then go further into the analysis. We can do analysis directly on the grinded materials. We can do thermogravimetric analysis for weight loss during heating. We can determine the water content, organic carbon content, and the carbonate content. We can also do the elemental analysis for the sulfur and carbon content. With the gamma counter, we can determine the age of the sample using the decay of isotopes, and with the X-ray fluorescence, we can determine the elemental content from sodium and upwards using tablets or glass beads.
Measuring the elemental composition of solid materials is of great importance for many types of research in earth sciences. For example, determining the concentrations of metals and nutrients is important for mineral exploration, or to determine whether the concentration of a metal is above toxic levels in the soil or in the context of assessing the fertility of soils. The elemental composition of rocks or sediments can also provide information about their origin or their formation. For example, the ratio between titanium and aluminum in sediments from the Mediterranean Sea can tell something about the input of titanium-rich sand from the Sahara, which comes in by wind, and from aluminum-rich clay minerals, which come in via rivers. By this, we can tell something about the climate in the past. In earth sciences, we also investigate specific processes which affect the composition of solid materials. For example, the weathering of a soil affects the ratio between silicon and aluminum. Or another example is that the degradation of organic matter is reflected in the carbon to nitrogen ratio, for example in sediments. So by investigating the elemental composition of these materials, we can learn more about the processes which affect our current environment, but also very important in Earth's history.